To Math Fun, simplifying rational functions, presented by Jana Isam. First of all, we will talk about rational functions and radicals. The rational functions are expressions that represent the ratio of two polynomials. Simplifying them makes it easier to understand their behavior, find solutions, and avoid mistakes. Radicals, such as the square roots, also require simplification, enhance clarity, and enable easier calculations in math problems. By simplifying these expressions, we can uncover their true essence and make complex problems more approachable for us students. Let's dive deeper into these fascinating mathematical concepts. Understanding rational functions basics. So the definition of a rational functions is the rational functions are defined as the ratio of two polynomials where the numerator and denominator can be any polynomial expressions. A visual example of a rational functions, a simple example of a rational function is x plus 2 and x minus 3, showcasing how a different polynomial equations from functional relationships. Explanation of domain restrictions. Domain restrictions occur when the denominator equals 0 and these values make the function undefined, leading to crucial mathematical considerations. A key vocabulary. To simplify rational function effectively, it's crucial to understand a key vocabulary. The numerator is the top part of a fraction while the denominator is the bottom. These two components create a ratio of polynomials. Additionally, recognized factors is essential as they are numbers or expressions that can multiply together to yield another number or expression. Finally, the term simplify refers to the process of reducing a fraction or expression to its most basic form. Simplifying rational functions, key steps to success. A review factoring polynomials. Factoring polynomials is crucial for simplifying rational functions, enabling us to identify common factors and understand their rules in the simplification process. Cancel common factors. After factoring, we can cancel out the common factors in the numerator and denominator, making the calculations simpler and cleaner for further analysis. Examples from simple to complex. Engaging examples ranging from basic to complex here reinforce our understanding of rational functions, showcasing real-world applications and enhancing problem-solving skills. Understanding radicals and their properties. What is a radical? A radical is an expression that includes a root sample, indicating the extraction of square roots, cube roots, or higher roots from numbers. Radical notation explained. Radical notation involves using the sample, followed by a number showing the value that when multiplied by itself equals that number under the root. Properties of radicals. Radicals follow specific properties including their product rule and quotient rule, which help simplify expressions and combine roots effectively for easier calculations. Fun practice problems to engage students. Playful contextual problems. Engage students with fun scenarios like a pizza slices or treasure chests to simplify rational functions and radicals in a relatable way. Mixed problem sets. Provide a variety of mixed problems that incorporate both simplifying rational functions and radicals to reinforce the concepts learned in class. Collaborative class discussion encourage participation and group discussion on solutions with prompts like how would you simplify this to foster interactive learning. Common mistakes in simplifying functions. Forgetting domain restrictions. It's crucial to remember domain restrictions. Ignoring them can lead to incorrect results. Ensure the denominator is never zero when simplifying functions. Incorrect cancellation of terms. Many students cancel the terms that are not actual factors. Only cancel the common factors from both numerator and denominator to avoid mistakes. Oversimplifying radicals. Simplifying radicals can be tricky. Ensure all factors are extracted fully. Underestimating this step can leave expressions unsimplified. Example 1. So first of all, we will talk about the understanding the radical. The expression of 50 square root represent the square root of 50. This means you are looking for a number that when multiplied by itself equals 50. 2. Factoring the number inside the radical. To simplify square root, you can factor 15 to the prime factors. The prime factorization of 50 is 50 equal 25 multiplied by 2. Here, 25 is a perfect square since 5 times 5 equals 25. 3. Rewriting the radical. Using the factorization, you can rewrite the square root. Square root of 50 equal 25 multiplied by 2 square root. 4. Applying the properties of square roots. The property of square roots states that a multiplied by b square root equal a square root multiplied by b square root. So you can separate the square root. 50 square root equal 25 square root multiplied by 2 square root. Then we will simplify the further. Now simplifying 25 square root equal 5. Therefore, substituting back, you get 50 square root equal 5 multiplied by 2 square root. The final result is the simplified form of 50 square root is 5 2 square root. Example 2. Simplifying 72 square root. Step 1. Factor the number. Start by finding the prime factorization of 72. You can break it down as follows. 72 equals 36 times 2. Here is 36 is a perfect square because 6 times 6 equals 36. Step 2. Rewrite the radical. Rewrite 72 using the factors. 72 square root equals 36 times 2 square root. Step 3. Apply the property of square roots. Use the property of square roots, which states that a times b square root equal a square root times b square root. It will give you 72 square root equal 36 square root times 2 square root. Step 4. Simplify. Now simplifying 36 square root. Since 36 square root, substitute this back into the equation. It will give you 72 square root equals 6 times 2 square root. Example 3. Simplifying 200 square root. Step 1. Factor the number. Start by finding the prime factorization of 200. You can break it down as follows. 200 equal 100 times 2. Here 100 is a perfect square because 10 times 10 equal 100. Step 2. Rewrite the radical. Rewrite 200 square root using the factors. 200 square root equal 100 times 2 square root. Step 3. Apply the property of square roots. Use the property of square roots, which states that a times b square root equal a square root times b square root. It will give you 200 square root equal 100 square root times 2 square root. Step 4. Simplify. Now simplify the 100 square root. Since 100 equal 10, you substitute this back into the equation. 4. Now simplify the 100 square root. Since 100 square root equal 10, you can substitute this back into equation. It will give you 200 square root equal 10 times 2 square root. So the summary of steps 1. The first one is factor the number under the radical into the perfect squares or cubes. 2. Rewrite the radical using these factors. 3. Use the property of square roots to separate the factors. 4. Simplify the perfect squares or cubes to get the final result. Finally, I hope you enjoyed it and thank you for your listening.